Designing an enterprise wireless LAN is a completely new arena, even if you're an experienced network architect. While designing a wireless network, the main design consideration is to plan for both capacity and coverage. Actually, if you ponder for a moment, you'll conclude that if you plan for adequate capacity, sufficient coverage will automatically result. If you deploy a single access point based network for a work group or a small area, then coverage will be the main design criteria. However, if you're designing the network for a complete enterprise, then definitely capacity or bandwidth will emerge as the main design criteria. But how do you know how much bandwidth will be adequate? The main factors to determine the bandwidth requirements are the total number of users and the applications they use. While designing a wireless LAN, you must be clear about the number of users within your access point's range. The next consideration while designing your wireless LAN will be to determine the size of the area of the network coverage by calculating its width and length. You can divide the building into multiple areas or departments on the basis of their bandwidth requirements. For example, the production department may require more bandwidth than the sales and marketing department, and areas like conference rooms or lab rooms may require high bandwidth. You can calculate the total bandwidth required for the area by multiplying the average bandwidth needed per user by the number of users in that coverage area. After these design considerations, next comes the installation considerations, where the starting point will be to determine the radio frequency coverage or RF coverage of your access point. This is done in order to ensure that enough capacity is available to support all the users of the particular wireless LAN, along with accounting for RF signal loss factors. To determine the RF coverage, you need to perform an RF site survey. This survey will provide you information about the best location and the appropriate number of access points you would require in your wireless LAN. In addition, the RF site survey will investigate any RF interferences and will lay the foundation for planning the countermeasures that you need to improve the performance of your network. The major RF interferences in an enterprise setup can be objects such as concrete walls, ceilings, other walls, wooden windows, and doors and tables, which absorb RF signals and cause signal loss. The main difference between designing for wired and wireless LANs is the impact of objects on RF signals. You can also increase the size of the coverage area of an AP by using specialized antennas. Most access points reduce their data rates automatically if the RF signal degrades because a lower frequency signal has a greater chance of going through when there is interference. To avoid this low performance for all users associated with your access points, you can set minimum association rates, which will force users to roam to a new access point if the throughput falls below the minimum rate. If you're deploying a wireless LAN for a large office with a large number of users, you can design smaller cells with higher throughput because in a large office, many RF interferences are present that may block the RF signals. With smaller cells, you'll need to reuse frequencies more often and ensure that the channels do not overlap. A good rule is to allow 2 megabits per second downstream and upstream per user for an 802.11a network and 500 kilobits per second each way for an 11b network. For big enterprises with a high density of users, 802.11a is a better choice because of its higher throughput and non-overlapping channels.